spinothalamic tract can be considered the main pathway that transmits pain information to the cerebral cortex. It is represented here by the purple nerve fiber travelling up the spinal cord, through the medulla and to the thalamus. In the thalamus, the fibers synapse with thalamic neurons that carry the signal to the somatosensory cortex. The spinothalamic tract contributes to our sensations of pain, temperature, non-discriminative or crude touch, and pressure. It is an ascending tract which carries sensory information from the skin, up the spinal cord to the thalamus of the brain, as the name suggests. The signal ends in the cerebral cortex, where we become conscious of the sensation. There are two major pathways of the spinothalamic tract: the anterior column, which is responsible for pressure, light touch, tickle and itch information, and the lateral column, which is responsible for pain and temperature. Here is an example of how the spinothalamic tract works.
Hey man, do you want to watch a game right now?
Yeah man, let me just make a sandwich.
Let's call a doctor.
I'm a doctor, and I can help you. But wait, let's explain this first.
When the thumb gets cut off, the pain travels up the nerves in the arm before entering the spinal cord. At the spinal cord, in the cervical region, the pain signal synapses with the interneuron at the same level. The signal also returns down to the thumb. So first, let's talk about the withdrawal reflex. The withdrawal reflex is a spinal reflex intended to protect the body from injuries and further damage. It is defined by an automatic withdrawal of an extremity such as the hand from a painful stimulus. It is a polysynaptic reflex that causes the stimulation of sensory association and motor neurons. In this scenario, nociceptors in the thumb detected the knife cut that breaks the skin and muscles. The pain signal travels through the first-order sensory neuron in the median and radial nerves. They then move into the brachial plexus. The median nerve will split into the lateral and medial cords that enters the spinal cord through the dorsal horns at C5-C6 and C8-T1, whilst the radial nerve enters the posterior cord and enters the spinal cord through the dorsal horns at C5-T1. The first-order neuron will then synapse with an interneuron within the gray matter. The signal is then processed in the interneuron and passed to an alpha motor neuron through a synapse. Subsequently, the motor neuron axon leaves via the ventral horn and will supply excitatory input to the ipsilateral flexor muscle group, namely the biceps brachii, coracobrachialis, and brachialis, with innervations from the musculocutaneous nerve flexing the arm and withdrawing it quickly. This sequence of events occurs involuntarily within half a second, or almost instantaneously. We now move on to the pain signal that travels up to the brain. A stimulus, such as pain, is detected by our first-order neuron. It is transmitted by first-order fibers to the posterior horn of the spinal cord, near the origin of sensation. These fibers are known as nociceptors and are specialized to detect pain. At the posterior horn, the first-order neurons synapse with the second-order neurons. They then decussate through the anterior white commissure. That is, they cross over to the contralateral side of the spinal cord. The fibers travel through the lateral column of the spinothalamic tract in the spinal cord to the medulla. Here, the anterior and lateral columns converge, alongside the spinomesencephalic, spinoreticcular, and spinohypothalamic tract, and together they form the spinal lemniscus. Do note that the spinoreticcular tract also contributes towards pain sensations. The secondary fibers then ascend towards the ventral posterior nucleus, or VPN of the thalamus, where they synapse with third-order neurons. These neurons cross the posterior limb of the internal capsule, followed by the corona radiata, before reaching the primary somatosensory cortex. At this point, the person becomes conscious of the pain.
So that's what happened. Nah, he didn't make it.